this video. In this video, we'll discuss how CMOS inverter works. CMOS means complementary metal oxide semiconductor. Normally, it's called MOS system. It's called metal oxide semiconductors. It's complementary. That means if you give the input, suppose 1, then if this is the logic symbol, the output give you 0. If you apply the 0, output give the 1. That means if you apply the high signal, that means higher voltage signal, it will be the lower voltage signal. And if you apply the low voltage signal, it should be the higher voltage signal. That's why it's called inverter. It's a NOT gate. This one. This one. Okay, so if 0, 1, 1, 0. So, what is the basic circuit? This is PMOS and this is NMOS. Normally, this is enhancement type MOSFET, metal oxides, semiconductor field effect transistor. These are not BJT, backward junction transistor. So, these are the FET field effect transistor. So in case of the, this is the PMOS and this is NMOS, both gate terminal of the PMOS and NMOS was connected. And in case of the PMOS, this is source, this is drain, and in case of NMOS, this is drain, this is source, both drain is connected, and you take the output from the connected drain. So this is parasitic capacitor, it's not the external capacitor. The capacitor is generated by when you manufacturing the MOSFET. It's very important to understand the concept how the CMOS inverter works. So if you apply suppose 1, what happens is that if you apply 1, that means a higher voltage. That means a positive voltage. And 0 means the negative voltage. You can say 1 means higher voltage, 0 means lower voltage. So if you apply 1, then what happens? This transistor going to be the, it just completed, this transistor going to the off, and this transistor going to be the on. Then what happens is that the output voltage, this is off, that means it's some look like this one. The output somehow connected to the ground, and whatever charge is stored on the particular capacitor, the parasitic load capacitor, this discharge through this NMOS transistor on that particular time, output equal to 0. That means if you apply 1, output is equal to 0. So if you apply 0, then what happens is that this particular transistor is on and this transistor is off. When this is off, what happens is that this parasitic capacitor load is connected through the power supply. Whether it's a 5 volt or 3 volt, then the particular capacitor is charged. On this particular time, if you calculate what is the voltage of the output, then you go the higher voltage is considered as 1. That means if you apply 1, this transistor is off, this is on. All charges discharge to the NMOS, so output equal to 0. When this is applied the 0, this transistor is on, this transistor is off. Your output capacitor is connected to the power supply. Then this charge is full charge up. That means the capacitor is full charge up. Then output equal to 1. So if you want to more understand when you apply the 1 and 0, how the transistor is on and off. Suppose if you get an NMOS enhancement type MOSFET, this is NMOS. If you apply suppose 0 means a lower voltage, then what happens? This transistor is off. That means if you apply the gate terminal, negative terminal, how the NMOS is work? This is P substrate and this is the P substrate, holes are majority carriers, electrons are minority carrier. And if you apply the positive charge here, what happens is that the electrons are approaching towards the gate terminal and they form the channel. Because you put the negative terminal, so this negative repulsion, so all the electrons going towards the gate terminal. So they form the channel, and when the channels are, when they form the sufficient channel, this is positive terminal, this drive the electrons and current flow in this direction. That is NMOS start conduct, and this minimum voltage, in which minimum voltage, gate input voltage, the channel is formed, is called nominal threshold voltage. Threshold voltage. Suppose if we apply now negative is this is negative, and if negative going to the repulsion, and what happens is that due to the repulsion, this negative and again electron going this side, so it cannot possible to form the channel. That's why source and drain are disconnected. So ID current on the particular time is equal to 0. So when you apply the 0, then it's off. When you apply the 1, this is on. Same as in case of the PMOS system, PMOS enhancement type MOSFET, what happens is that if you apply suppose N type means majority carrier electrons and holes are the minority carrier. If you apply positive voltage or negative voltage here, what happens is that it attracts the holes. and all holes are approaching towards the gate terminal, and also this substrate bias voltage helps to approaching the holes towards the gate terminal, and they form the channel. When they form sufficiently channel, then this negative terminal attracts the holes and they start current. ID current, electrons toward in this direction, and the ID is not equal to 0. And if we apply, suppose this is positive terminal, what happens is that when the positive pole on hole, this is going to repulsion, so it's not possible to form the channel just near about the gate terminal. Due to this, the drains and source are disconnected. On this particular situation, ID current equal to 0. So simply we can say when this is 0, this is on, and this is 0, this is off. When this is 1, PMOS is off, and this is on. That's why when we apply the 1, then what happens is this is off, and the output capacitors discharge through this NMOS transistor. On this particular time, output equal to 0. And when we apply the 0, then what happens? 0, this is going to the 1, and this is off, that means it's disconnected, and the output capacitance is connected to through the PMOS to power supply. Then capacitor is full charger, then you can say higher voltage is 1. So if you check what is the voltage transfer characteristics, see when the input voltage is low, some output is equal to high, and when input voltage is high, output becomes 0. But in this particular situation, when you somehow if you go from 0 to 1, and suppose that means from 0 voltage to 3 voltage, somehow in between 1.5 voltage or 1.6 voltage, what transistor is on? Depending on the particular time, what transistor in the saturation region, and during the saturation region, what transistor conduct is also ID current due to the PMOS, and it's give the ID current due to the NMOS. So that if you check the maximum current when the what transistor is on. But in this situation, one transistor is on, and this situation, one transistor is on. That's why during the CMOS on or off, almost current ID is approximately equal to 0. That's why no power consumption during the on or off. Maximum power consumption during the transition from higher to lower and lower to higher. And this is the basic concept of how this we can say whether 0 apply on or off. This is enhancement atmosphere. That means you can enhance the channel just near about the gate terminal, and they start conducting. And thank you very much for watching this video.